Let's now look at something called the base change formula. What that says is if you have log base b of m, that can be rewritten in terms of another base a, log base a of m over log base a of b. And I'll show you why that's true in a little bit, but the useful thing about this is that you can rewrite log base b of m, or of anything, in terms of any other base that you want. And this is often useful because you could, for example, write this as log base 10 of m over log base 10 of b, so just log m over log b. It's also true that this is equal to ln m over ln b. And even though this looks exceedingly improbable, this is the base change formula. Let me give you a couple of concrete examples using numbers, how this works, and then we'll look at why this is actually true. So for example, we can take log base 3 of 7. Now this number, if we wanted a decimal approximation for it, we could try to use our calculator, but the problem is that your calculator doesn't actually have a log base 3 button. What it instead has is a log base 10 button and a log base e, which is the ln button. So we can take this and we can rewrite it using either log of 7 over log of 3 or ln of 7 over ln of 3. And if you calculate either of these ratios, in fact, it might be a good idea to calculate both of them just to make sure, just to see that this really does work, then you find that the decimal approximation for this, I'm just going to use the approximately equal to sign here, is about 1.77124. That's true whether or not you use the log expression or the ln expression. And if you think about it, 3 raised to the 2 power is 9, 3 raised to the 1 power is 3, and so the number, the exponent on 3 that would give you 7 would be somewhere in the middle. Let's take a look further. I'm going to scroll down a bit and see why the base change formula works. Well, let's take a look at the following example. Suppose we are to solve for x in the following equation. B to the x is equal to c. If we use the method we've been using up until now, method number 1, again, I'll scroll down a little bit. It's a bit too far. There we go. If we use the method we've been using so far, which is to rewrite this in exponential form, rewrite the exponential equation in logarithmic form, you can see that we would get that x equals log base b of c. But let's use method number 2. Where I can take this, b to the x equals c, and I can actually take the logarithm of both sides. Then we know that we can use the power rule on the left-hand side to get x log b is equal to log c, and so x is equal to log c over log b. And so you can see here that this expression and this expression must be equivalent because they're what you get when you use legal methods in order to solve for x. Leaving us with the conclusion that log base b of c is equal to log c over log b. Now for convenience I used logarithms base 10 on the right-hand side, but I could use log base a on both sides, and so I'd get log base a of c over log base A of B. Anyway, so that's why the base change formula works.